Enterprises are racing to adopt AI systems. But what happens when an AI agent attempts to access a database and accidentally leaks sensitive MNPI? Let's see how you can dynamically control access with a secured end-to-end AI flow. Let's take, for example, a department manager who has limited access. He asks, "What were our Q4 financial results?" In this example, we can see the input guardrail, prompt categorization, where access is denied at the prompt level. Because the department manager doesn't have sufficient permissions, the answer is blocked at the very beginning of the flow. Now, let's look at an executive who has full access. She asks the exact same question. First, we see that access is granted at the prompt guardrail. Next, at the data retrieval layer, we see the filters applied and that only the 5 relevant documents were retrieved. Finally, at the output guardrail, no redaction was done. Based on the executive's role permissions, full access to the financial data is granted, and we can see the full response. Now let's compare the PlainID secured AI flow with an alternative approach. Let's look at the department manager with limited access again. On the left, we can see that when no prompt classifications or data filtering are applied, the full financial data is displayed to the unauthorized user. But on the right, we see that PlainID has applied all layers of control. The prompt was classified, authorization denied, and the access denied policy-compliant response was presented, protecting the sensitive data. PlainID stops the retrieval. We filter the documents and redact the output before the LLM can even process it. The result? The user gets a clear access denied, no data leakage, and MNPI remains secure.